This is Jeff Hamrick at Rhodes College, and we want to wrap up our analysis of this dichotomous by dichotomous set of data that we've been working with. In our most recent video screencast, we created a randomization distribution, a visualization of this randomization distribution. Our randomization distribution was the collection of all of the measures that we took over all of our samples without replacement. We also plotted the measure of interest, that is the count of the number of times that the man approached the woman at the bar, from our original set of data. We plotted that on our randomization distribution as this blue line. Okay, and we noted that the number of dots to the left of or at this blue line compared to the total number of dots here seems very small, and that indicates that smiling does seem to matter if you would like a man to approach you at the bar, basically. So what we want to do now is compute that a little bit more rigorously, and here's how we do so. Double click on this measures box. It will probably be defaulted to the collect measures tab. We don't want to collect any more measures right now. We could do that. Instead, click over to the measures tab, and we're going to define a measure on the measures. It's going to be called the empirical p-value. Okay, and its definition is going to be exactly what I said just a few minutes ago. Double click on the formula box here and bring up the formula wizard. It's going to be the count of all of those measures. Remember, we called our measures the count of the approaches, so it's going to be the count of the approaches that are less than or equal to 2 divided by the total number of dots. So we don't have a less than or equal to here. To get it, press the control button, and notice how our options change in the formula wizard when we do that. Press the control button down and click on less than or equal to right here. Then press 2. Highlight this entire line. That's going to be the numerator in a fraction now, and press divide. And the denominator, we could put 1,000 in here because we have 1,000 total measures that we collected right now. But that number could change. We could generate more measures. Let's not handle it that way. Let's press count. Let's type in count of the count of approaches. Okay. That's going to always track the total number of measures that have been generated. So the numerator has the total number of measures that are less than or equal to 2. The denominator has the total number of measures. That's the relative frequency that we were interested in this case. So press OK, and we see that this empirical p-value is 0.033. There are a few different interpretations of this probability value. Here's one. That's the chance, that's the probability, an estimate of the probability that the apparent connection between the smile effect and whether or not the man approaches the woman at the bar is due to experimental variation, is due to random experimental variation. That probability is not very large in this case, which suggests that in fact, if you are a woman at a bar, smiling at a guy rather than just glancing at him is going to greatly improve your chances of having that man go on ahead and approach you at the bar.